This video, we're going to learn about graphing the sine function. So let's get started. If we remember what our unit circle looks like, okay, the key points on our unit circle, right here I'm crossing the x-axis, and since it's a unit circle, it's 1, so that's going to be at 1, 0. Up here, I'm going to be on the y-axis, so we're going to be at 0, 1. Over here I'm going to be on the x-axis, so this is going to then be negative 1, 0. And here we're on the y-axis, so then this is going to be 0, negative 1. Alright, let's go ahead and figure out some in-between points. This is about 45 degrees, or pi over 2. And this one's then going to happen at the square root of 2 over 2, square root of 2 over 2. The same thing's going to happen over here at 3 pi over 4, except the x value is going to be a negative number. Down here at 5 pi over 4, then we're going to be dealing with negative square root of 2 over 2, negative square root of 2 over 2. So let's go ahead and start thinking about this in terms of our sine function. Our sine of theta on a unit circle is then equal to y. So we know what the sine of theta is based on our y values. Let's go ahead and do up a chart. So we'll call this theta and sine of theta. Alright, our first point here is we're on that x-axis, so this is going to be 0, and the y value on the x-axis will be 0. Pretty straightforward. At pi over 4, on the y-axis, we're then going to be square root of 2 over 2. Then at pi over 2, on the y-axis, we're going to then be at 1. At 3 pi over 4, okay, the y-axis is going to give us what? That y value is going to then be square root of 2 over 2. At pi, what is happening here? This is going to get interesting. We're back at 0. So, look at what's happened. We started at 0. We're now getting bigger. We're at the top, getting smaller, and we're back at 0. Five pi over 4 is then going to put us at, now we're down here, so that's going to give us what? That's going to give us a negative square root of 2 over 2. Let's just write two more of these down. At 3 pi over 2, we're going to be at a negative 1. And finally at 2 pi, we're back at 0. Just looking at these numbers, you're going to start to see the periodicity of the sine come through. And we're going to label these because when we go to translate these sine functions, they're going to become rather important to us. This is an intercept, which makes sense. It's where it's intercepting the x-axis. I have another one down here, and I have a third one here. Now if we look at our y values, the top y value we're going to see is at this 1 here, so that's going to be a max. The bottom y value we're going to see is this negative 1, so that's going to become our min. Now we can think of this, instead of theta and sine of theta, as an xy chart. Let's go ahead now and taking these values, let's graph it out and see what our basic sine curve is going to look like. Okay, so these are the values that were on the previous slide. and let's go ahead and start graphing this. First off, we need to label our axes. So on this is going to be my y-axis, or my sine of theta. It's our y-axis here, so this is going to go from 1 to -1. Alright, and then we're going to have what? We're going to have a pi over 4, a pi over 2. This is going to be about 3 pi over 4. Here we're going to have pi. This here is going to be 5 pi over 4. Let's move that. Let's erase that and move that over a little bit. Okay, here we go. This is roughly about 5 pi over 4. This is then going to give me here 3 pi over 2. Here we're going to have 7 pi over 4, and then finally here we will have our 2 pi. Alright, at 0, our first point here, we're at 0, so that's going to put us right here. At pi over 4, right, we're at square root of 2 over 2, so that's going to put us roughly there. At pi over 2, now I'm up here at 1. Remember, we said that was a maximum value, and we're going to see that come through. Then at 3 pi over 4, now I'm back at the square root of 2 over 2, and at pi, I'm at the intercept. 5 pi over 4 is going to give me a negative square root of 2 over 2. 3 pi, we have an intercept. Oh, 3 pi, we do not have an intercept. Let's look at this carefully. What's happening here at 3 pi? Right? That's not an intercept. That's our minimum. 7 pi over 4. And then 2 pi is where intercept is happening. So let's go ahead then and sketch this through. Alright, there's our basic sine curve. Remember, what did we say was going on here? This is our max, and this here is our min. A couple of other things I want to point out. First, let's talk about domain and range. Are there any x values this can't be? No. So, our domain is going to be our real numbers. But what about our range? Our range is limited. It's only going to run from -1 to 1. Let's talk about what's going on with the height or the depth of this curve. This distance here has a special name, and that is called the amplitude. And we refer to it then as A. Another item in the graph that will have a special name, if we come here and here, this distance here is called the period. And the period is when this graph will start to repeat itself. So the period is then defined as what we're going to call 2 pi over b. This a and this b are going to help us figure out how to translate those out. And let's just get a peek at what's going on with that, and we're going to do that with this cool little function here. Alright, so what did we just graph? We just graphed a function that looked like roughly like this. Alright, and that's what we were graphing just a minute ago. Oh, that's not going to work, is it? Alright, this is what we just graphed. Now, let's take a second and look at this and see what's going to happen. This a value sits in front of the sine. So if I change my a value, notice I'm going to be pulling or stretching this graph. The b value directly affects the period. So notice, as the b value gets bigger, the graph in essence compresses. It's going to get together. Finally, and let's go ahead and uncompress this so we can see a little easier, what's going to happen with the c? Now the c is part of this sine expression down here. All right, this is what I'm looking at. That c value, as I change the c value, I'm going to start actually having a horizontal shifting occur. The next video will then be about how we graph when we're dealing with a translated sine graph and we have this change in amplitude as well as the change in period and then the horizontal as well as vertical shifting.